What I'm going to present today is basically, I guess, an update from kind of a natural perspective and how the Corps of Engineers is developed over the last, I would say, 5 to 6 years for inland restoration, looking at engineering with nature. And engineering with nature is a process of looking at some of the practices that we've been doing for many, many years, but then also looking and trying to get information from the practitioners in the field that may be doing restoration practices a little bit different than what the Corps has typically done from our original portfolios. So engineering with nature in itself, it's a pretty ubiquitous term. It kind of encompasses a lot of different perspectives, but this is the definition that we use, the alignment of natural processes in engineering, economic, environmental, and social benefits through collaboration. And so collaboration, that doesn't mean come to the table and tell people what they're going to do. That means develop a process and develop and gather all the information we need as a group to make good decisions. And so, sometimes we don't always do this. We get stuck in our ways. And so I look at this as a really good opportunity from the Corps perspective to work with partners a lot more effectively. And there's basically 4 key elements to this, at least that we outline. Now, within each one of these key elements, there's a lot more details, but those key elements are listed here in the bullets. Science and engineering. So, what are the expansions of our scientific knowledge, engineering, and then understanding of natural processes. I think most folks in this room realize that we've got a lot to learn as we profess and progress into the future, is trying to understand those natural processes and how they can impact our designs and make them more sustainable and more resilient in those designs. Second bullet, natural processes, understanding those natural processes, not just studying them and then not incorporating them into our designs. So very important. With the Corps, we have in the past had some very stringent guidelines on how we describe our benefits. And so from a headquarters perspective, there's been a big push to look at other benefits, not just benefit cost ratios or habitat benefits, but also the wide range of social and economic benefits as well. And then the final bullet, I think, is probably as important as any of them. It's grouping all of these together in a science-based approach where we're collaborative. Again, we're not coming to the table and just saying this is what we should do. We're gathering the information, you're gathering the information. We're having meetings like this to learn from each other and how we can comprehensively put those plans together. And so very, very different approach than maybe what the Corps has done in the past. And so this is really exciting to me, and I know that the districts as well. It's being kind of released to the districts, and some districts are doing a lot of this work already. So just a kind of a quick description of those 4 topics. Every project isn't developed the same. You may have a site-specific location where you need to protect infrastructure, or you have just a specific project that you're looking at a specific region, or you might have a large project where we're looking at watershed restoration, like the Santa Clara Pueblo. And so the degree at which each one of these elements can be described is going to be different in each project. And so we need to be flexible with those elements and how we describe them as well, and how important they are for each project. And so why does that matter with EWN? Well, over the last 200 plus years, we've had a lot of impacts on the landscape, right? For those of you familiar with St. Louis, this is the Gateway Arch, and looking over into Missouri from the Illinois side. And so we've done a lot of things to change our watersheds, to change our locations, and all of these have differing effects. They all make impacts in different ways. And when we do them in coordination with each other, they make things even more difficult. I know I'm not mentioning anything in these slides that the group doesn't know here already. These are all impacts. In many cases, we're still fighting against a lot of these anthropogenic processes that we've created. And so within the engineering with nature perspective, we're trying to look at a systems approach and really pushing understanding the natural processes within that system. Depending on where you're at in the country, we may have groundwater recharge issues where we've got incised channels, where we've got wildfire recovery efforts. We may need some kind of sediment retention structures, where we've got lack of floodplain connections on some of the southeastern streams. Maybe we need grade control. And implementing those projects in a systems approach from a watershed perspective is really important. So thinking about the scale of the project and how that fits within the landscape. I would mention here too, we do have what's called the international guidelines for natural and nature-based features. I've got a web link on here that will be available when you get the slides. That'll be posted either later today or tomorrow. And so NNBF, natural and nature-based features, is just a component under engineering with nature. As with a lot of federal agencies, we like to make acronyms. And so NNBF is natural and nature-based features. You might also hear NBS, nature-based solutions. They're all the same. It's just another way. It's just another way of wrapping those topics. But in this case, we look at engineering performance and how that relates to benefits and processes and then performance factors. And I think one of the things that we really need to start keying in on, I taught a class last week in Missoula, Montana, and it was with about 6 different organizations, and none of those groups were doing any monitoring of the projects. And that each project had different perspectives and different goals and objectives, but qualitatively, we really know that we're doing good things, right? But quantitatively, we really need to try to stress more of the monitoring so that we know what kind of adaptive measurement things we can do to make these designs better. Again, I think most of the folks in this room are aware of those type of issues, but it's something that we really need to stress. Whether it's levee setbacks, naturalization of channels, or watershed treatments, we've got scales of different proportions that we need to consider for each project. And then this bell curve is a figure that we've developed, actually working on a paper to discuss these kind of spectrum of projects that we look at and that we've been building for many, many years. On the right side of the curve, where you see the full bank armor, the red kind of hash underneath the curve, you can see down in the right corner, we've got some really ugly looking structures, right? And those are things that we want to try to stay away from when we can. The lower right-hand photo there is of Lincoln, Nebraska, and that's some of the riparian corridor recreational area in the downtown. And so you may be locked into using more structurally applicable approaches where you can't use softer designs. If you think about the left side then, where we're purely vegetative, then we've got different perspectives there. Maybe we're in an area that's rangeland where we can build structures that back water up, maybe recreate wetlands. For those of you familiar with stage 0, maybe those are some areas where we could use just vegetation and low-cost alternatives. Excuse me. Most of the projects that we're working in typically are in that middle, that hybrid section, where we're trying to do some natural processes with vegetation and then probably some hard structural mixed in. And if we can tease that to the left side as much as possible, then we're going to introduce or reintroduce more of natural processes in our systems and our designs. And so this figure in particular really kind of lays out the engineering with nature perspective and how we want to apply natural and nature-based features, whether it's wildfire recovery or just channel instability projects. So with ERDIC, Engineering Research and Development Lab, we do have the potential, and actually we do a lot of research, and so using natural materials is very important to these projects. And so developing partnerships with these local groups, this room in particular, you guys have the expertise for the Southwest areas along with the core districts, Albuquerque district. So trying to kind of tailor our designs based on the information that you know, that the local districts know, is very important. And so developing and looking at research that we need for maybe wood structure designs. We've got an EWN project right now that's looking at implementing wood structures in the HEC-RAS program so that we can actually put those structures into a hydraulic model and design them effectively. There's a lot of challenges with that, but that is one of the projects, one of the research projects we're working on at this point. We've also got the National Large Wood Manual, which was done in partnership with the, I believe the Forest Department. And there's a web link at the bottom of this page for the Engineering with Nature web page that has these resources. Invite you all to take a look at that web page because there's a lot of different information that's very applicable to a lot of the projects we're doing and probably a lot of the stuff that you're doing as well. So what types of processes can we do with engineering with nature or just the restoration practices? In this case, I've got a slide looking at some simple toe protection, minimal usage of rock at the toe to stabilize the active erosion and then letting the mid and upper bank stabilize, which is the right photos, the upper right and the lower right photos. And then the left-hand photos there on Copperas Creek. In this case, we actually pulled that toe protection out and built a floodplain reconnection on that outside meander bend. So there's a lot of benefits to reintroducing floodplains, right? We dissipate energy, we have nutrient recycling potential. Vegetation was not planted in that location, but the willows are taking over that new floodplain. And so instead of having a vertical eroding bank, we've got a bank that's healed and has basically a wetland complex there. The other thing that's not shown in that lower left-hand photo is there's about a 12-inch tile that comes out and delivers water from the agricultural field there. And so there's nutrient recycling from the actual tile lines that's going on in that wetland as well. And then restoring natural processes to degraded channels. The upper right-hand photo is a pretty famous photo from Crider Creek in northern Mississippi. You can see right here is a car body. That's the scale. And the watershed is about 2 square miles and about 2 square miles this way. So this isn't a large watershed. It's a very small watershed. But the degradation, the channel degradation that occurred just rips these watersheds apart. Very similar to some of the upper tributaries in Clara Pueblo. I think this afternoon we're going to go to Switchback Canyon and some other locations maybe tomorrow. So where you had 2-foot wide channels, maybe 2 foot deep, and in some cases maybe no channels at all, you're looking at 30 to 40 to 50 feet wide and 10 feet deep. So massive amounts of sediment coming out of these tributaries, and just a lot of things that we can do to help stabilize those locations. For example, grade control. And the upper left-hand photo there, I've got a red circle with a cross through it here. Those are the structures we want to try to stay away from as much as possible because we lack fish passage, we lack reconnections to the floodplains, They may have their places in certain locations, but I believe that those locations are dwindling as we speak. So the good news is we do have natural structures that we can put in. The upper right-hand photo there is a Red Banks Creek in northern Mississippi. That channel was degraded by about 30 to 40 feet. A series of loose rock riffle grade control structures were brought in. And the lower right-hand photo there, you can see the berms that have built upstream of these grade control structures. These were put in back in 1998, so they've been in 25 years or so. The benefits of the sediment that's been collected, the nutrients that are being cycled, we're actually doing some research on this right now, but there is a tremendous amount of benefits to grade control where you can do them and where they're applicable. The lower right-hand photo is a Sinsinawa River in some of the driftless area of the Midwest, if anybody's familiar with the driftless area. That's another grade control project that was done to protect some bridge abutments, and that was done, I think, back in 2000, 2001. More examples of processes trying to naturalize with root wads, locked logs, all kinds of different projects that we can do to reintroduce that fish habitat, that aquatic habitat, areas for bugs to populate instead of just having a ubiquitous bank lining with riprap, right? And so we've got options to do these lower cost and more environmentally friendly projects. I had a conversation last night with a few folks here about beaver dam analogies, the applications of those in some of the upper parts of the watersheds, stage 0 applications. In Scotland, as part of the International Guidelines Manual, we went actually and looked at what they call leaky dams. Now, they're not reintroducing, am I not loud enough? They're not reintroducing beavers, but they are trying to use the minimal kind of cost perspective to stabilize some of these upper watersheds. And so the Santa Clara watershed, we've got our producing efficiencies. We've got basically our 4 bullets there, talking about the prospects of the engineering with nature collaborative perspective. Some photos there of some structures that were put in, and we assessed. Basically, ERDIC got involved with the Santa Clara Pueblo project back in 2017. We worked with Garrett on a DOTS request and looked at developing some recommendations, one of which was to start and working in those tributaries to reduce a lot of the sediment inputs from those degrading channels. And so I know a few folks are going to talk a little bit more about natural channel processes and natural channel design. I think Alan Hayden is going to talk a little bit later this morning about some of the Rosgan type designs. And you know, one of the learning perspectives that we got from a core perspective, myself included, was learning about traditional ecological knowledge and how that applies to the locations where we're working in these upper watersheds and how steep the locations are. Using large equipment is not applicable in a lot of these cases, and so we've got to try to come up with these types of methods to stabilize these areas. And as part of the DOTS request, it's a program within the Corps of Engineers for Technical Assistance. We assessed some of the canyons, and we're still in the process of kind of going back and looking a few years out to determine, you know, there's some things that we could do a little bit different on those designs or recommend. But just a lot of benefits, again, to reintroducing floodplains, using the materials, the wood materials to mulch and develop more organic materials within the watershed, floodplains and the reconnections, just vast amounts of information there. And in the lower right hand there is a paper that Garrett and I co-authored with a few other folks on traditional ecological knowledge and the Santa Clara Pueblo efforts. So here's an example of some of the structures I think we will see in Switchback Canyon later today. Bruce Bauer with Sustainable Ecosystems, I think, is going to be talking a little bit more details of these structures, and was instrumental in getting a lot of these structures installed, and learned a lot from Bruce as far as the capabilities of these crews, and again, just the limited access to these areas. And then I included a couple other EWN projects. This one in particular is shoreline erosion, and I'm sure with the reservoirs we have around, there's issues with shoreline erosion. This one in particular was done by a ranger in Louisville, Kentucky at the Lake Nolan Reservoir. She had taken one of my restoration courses, and she applied this toe protection, which you can see in the upper right-hand corner, to the shoreline erosion through conversations, and it's actually really nice to see students take the information you provide and actually put it in practice. The issue with using toe protection in a lot of these reservoirs is the shoreline is typically pretty deep right off the edge, and so you end up using a lot of rock. And so you can see in the lower right-hand corner, this is post-project stabilization. There's a lot of sediment and a lot of vegetation, a lot of willows that are coming up behind that, but there's a lot of material that was used, in particular a lot of rock. And so what we're looking at, I don't know if anybody's familiar with reef balls, that's more of a coastal setting, but we're looking at using reef balls and maybe some wood materials spaced in between them through the holes to try to provide more shoreline protection at a lower cost, instead of using a line of rock. And so they've got some active projects we're monitoring and helping with design. So if there's shoreline issues, this is certainly a work unit we're working on, and this has a web page within the EWN website if there's more requests for information. For those of you who fly into Denver, a lot of times you can see in the flat areas where the mining of gravels and other materials are done extensively along these river corridors, and Boulder Creek is no stranger to those mining techniques. The Omaha district did a remeandering project back in, I think it was 2016 into 17, where they came in and cut a floodplain, so reconnecting a floodplain. They used the in situ materials there, where they brought in grizzlies, which are basically sieves, to sieve the materials and then use those materials to actually construct the riffles right on site. And so they incorporated woody materials as well on some of the meander bends. And so this is what it looks like. I was there about 2 years ago, which is the lower right-hand photo and the lower left-hand photo. Can see that there's relatively quick access to the floodplain at that probably 1.5 to 2 year event. So again, we dissipate energy, we have a chance to recycle nutrients, potentially groundwater recharge, depending on where we're at in the watershed. But these are the type of projects that we're really trying to more focus on and construct from a natural perspective. And then Chusa Grasslands, this is a project I did with the TNC, Nature Conservancy, and the U.S. Fish and Wildlife. The right-hand photo there is an existing wetland that they had prior to, I think this construction was 2016. So we came in and built some shallow berms with some stop log structures to create more shallow wetlands upstream. And that's shown in that right-hand photo. So this is what we got. We got a decent amount of new wetland areas, and this area was being targeted for reintroduction of buffalo. And so what do the buffalo like? Well, they like those wet, marshy areas for forage and other kind of issues for water. And so there's a link there too to this website if anyone's interested to kind of go view that project. So EWN in perspective, building progress. This again goes back to those 4 elements. It's very important for us to be coordinating, to learning, to being accessible to the public, to groups like this, and all the individual groups within this room, so that we can learn and we can do projects and adjust our designs. And so there's been a lot of progress with the Corps over the last, I would say, 4 to 5 years in coordinating these EWN aspects. So I think from my perspective, the Corps has a bright future with coordinating and trying to develop more sustainable and natural designs, whether it be a small scale project or a large scale project. Again, we got to think about that bell curve and where we fit within that bell curve, because we're not always going to be on the left side where we can use all vegetation, and we don't want to be always on the right side where we're using hard materials. We want to be building more of those hybrid techniques and using some of the techniques that we've used over the last 50 years. And so this is the discussion of the international guidelines. I think there's 24 chapters. There's 5 chapters on fluvial inland geomorphology, and there's case studies within this document. The web link there is at the lower section, ewn.erdic.dren.mil, and really invite you to take a look and kind of delve into that website, because there's a lot of good information. All of our current EWN projects have web pages on there as well. So the Santa Clara Pueblo has a web page as well with some of the current core coordination.